Chapter 5 with 5.1 nth roots and rational exponents, along with evaluating with function notation. All right, so we are going to kick things off with just some basic rules about roots and rational exponents and kind of talk about what those different things are. So we have a couple of goals for ourselves today, 3 of them to be specific. We have finding nth roots, values, evaluating expressions with rational exponents, and solving simple equations with nth roots. So these are our objectives, if you will, for today. All right, moving right along. I want to show you a rule about exponents. But before we do, I think it might be good for you to just give some things a try. So while I wouldn't normally do this, you may not know what these particular exponents do. So I'm going to suggest that you type each expression in your calculator to evaluate. All right, so I want you to take a moment, pause the video, and evaluate each of the expressions that are in these rows, okay? So take a moment, hit pause, and then when you come back, I will tell you what the answers are. All right, welcome back. So if you typed these into your calculator properly, you should have gotten 10, 6, 5, and then you should have gotten 3, 2, and I've just noticed that there is a little tiny typo right here. We should actually have this say 1/3, because the correct answer here should be 5 as well. All right, now I'm hoping that you are noticing a connection between the original expression and the value. Okay, if you notice, how is 100 related to 10, or 6 related to 36, or 5 related to 25? Every value that we took to the 1/2 was equivalent to the square root of that value. Okay? And if you look at the next row of values, every value that we took to the 1/3 is the same thing as the cube root of x. Okay? So what we have learned is that taking something to the 1/2 power is equivalent to the square root. Taking something to the 1/3 power is equivalent to the cube root. So to continue that, if I took something to the 1/4 power, that would be the same as the 4th root, and so on and so forth. Okay, so very important to understand the difference between the rational, which is your fraction, versus your root, which has the big square root symbol. Okay, so if we take a look at a couple of other situations, 8 to the 2/3 would be the cube root of 8, based on what we just learned, squared. Okay, because if you pick that apart, that's 2 times 1/3, right? And we just learned that 1/3 is the cube root. And the cube root of 8, we know that that's 2, so 2 squared would be 4. And here, this would mean that we have the 4th root of x to the 7th power, right? Because really this is 7 times a 4th. All right, so in general, if you have a variable or number to some b, let's call it over n, really doesn't matter, then that is going to turn into the nth root, and x is going to be to the b power. Now that can either be inside the root, or it can be the nth root of that value, and then b can go on the outside. It really doesn't matter. So we could have also rewritten this answer here as the 4th root of x to the 7th power and had the 7b inside the radical. Really doesn't make a big difference in general, but it can make a difference when you go to evaluate, when you go to simplify something. Okay, so just as a little heads up, radical or root, whenever we see that, it means we're talking about an expression with an nth, n because it could be any sort of power of our root with an nth root. Okay, so nth root meaning like this. Okay, this could be any value greater than or equal to 2. Okay, that is something that you should know. N's going to be a positive integer, and it's going to be greater than 2. Okay, so remember that this represents the square root, that symbol, because there's a hidden 2 right there. We just don't always write it. And then we have our cube root. Those are the only 2 with special names. Everything after that, if we have a 4, we just call it the 4th root. Or like a 5. Oh my goodness. Sorry, guys. There we go. 5th root. Okay. But that does change how that simplifies, okay? And we'll talk a little bit about that later. A rational exponent, okay, very simply, that means you have a fraction as an exponent. And I've included some rules from our textbook about rational exponents. So generally speaking, they are involving a numerator and a denominator, right? You've got your fraction. At the bare minimum, we've got 1 over n. Okay, so that nth root m, if it's a number in the numerator, should be a positive integer, okay? So then all of this right here is true. And then if we have this right here is a to the opposite of m over n, okay? And just as a reminder, we'll talk about this more throughout this unit. Anytime you have a negative exponent, we take the reciprocal of whatever we are evaluating. So if you look, instead of having a to the negative m over n, we rewrote it as 1 over a to the m over n. And that is to help keep or avoid having a negative exponent, to keep a positive exponent as much as possible. Some other rules that I want to remind you of. I want you to try these problems that are over here on the left-hand column. And I want to see if you remember those rules, and then I'm going to go over those rules with you. So take a moment and pause the video and try some of those problems on the left-hand side. All right, welcome back. So if you've done your maths correctly here, we should get 2 to the 5th and x to the 12th. Okay, now in general, we add exponents if bases are multiplied. Now, in case you need a little refresher, these values right here, x and x, those are your bases. So those are the same, right? See how 2 is the base in both of those situations? So if you have the same, I'll include that word because I feel like that's important, if the same bases are multiplied. Now, as always, if you can evaluate it, if it's like of a reasonable value, then you should. So really, we would turn 2 to the 5th into 32 as our final answer. But we'd keep x to the 12th. All right. Now here we should have gotten 2 to the 6th and x to the 32nd. So in general, what do? We multiply exponents when they are power times another power. Okay, so in that situation where it looks like they're being multiplied, they really do get multiplied because they are both right next to one another, separated by that parenthesis. Okay, and once again, we're going to rewrite this as 64 because we can simplify that a bit further. All right, now this would be a situation where we rewrite 2 as 1 over 2 to the 1st, and we would rewrite this as x to the third. So basically, anytime you have a negative exponent, take the reciprocal. Sometimes reciprocal. Sometimes that means the value is going to go to the denominator. Sometimes that means the value is going to jump back up to the numerator. All right? Okay, in this situation, we would have 3 to the negative first because we subtract, and we would have 8x to the fifth. So subtract exponents. If we've got the same, this is important, just like in that one, the first one we did, bases are divided. Now, in this situation right here with 3 to the negative 1, we would rewrite that as 1/3. Okay, we would not leave it as 3 to the negative first. All right, and then last but not least, the key thing here is just to multiply like with like. So 2 and 2 are both coefficients, so those are going to give us 4. And then x squared and x cubed are both bases of a variable, so we would add their exponents together. So just remember to combine like, I want to say terms, but it's parts of each term. So that's what I'm going to include. Like parts of terms together using exponent rules, right? Another way to look at this is that technically you took 2 to the first and 2 to the first, and you wrote 2 squared, right? And then because you know 2 squared is 4, you simplified it a little bit further. So that might help really reinforce that. Okay, real nth roots of a. Okay, now this is important. If you have just been kind of writing some things down, this is definitely, hey, yo, pretty important information to make a note of, okay? So there are 2 situations that we need to be aware of. When n is even, there are 3 different situations. If n's even, and then you have a value a that you're taking the root of. So what this means is we're talking about the nth root of some number a, okay? If a is less than 0, we have no real nth roots. So this is the situation where we end up with possibly something that's imaginary, all right? If a is 0, you're going to get 1, because the square root of 0 is 0. And then this is the big one that people often forget. If a is greater than 0, aka positive, then you're going to get 2 real zeros. Remember that whole plus minus situation? So if we take a look at this first problem, in order to get rid of a 4th power, I'm going to use a 4th root. That should make sense. So then I'm going to get x minus 3 equals the 4th root of 21. However, because that's a positive number, 21 is positive, it's not just going to be one of those, it's going to be plus or minus. So when I go to add 3 to both sides, x is going to be equal to 3 plus or minus the 4th root of 21. And for right now, we're just going to leave those in exact form. We are not going to deal with rounding those. We'll get to that later, but for now, we'll just leave it just like that. Now, on the flip side, when n is odd, you're going to get one answer no matter what. Okay? No matter what, it's going to be one singular answer. So if I take a look at this problem, I divide by 4. And so I get x to the 5th equals 32. Okay? And then I'm going to take the 5th root of both sides because that's going to get rid of my 5th power. That's the undoing operation. And the 5th root of 32 is 2. That's it. I get one answer. 1 and done. Now, for comparison, suppose I had said that 4x to the 5th was equal to negative 128. So I divide both sides by 4. I get x to the 5th equals negative 32. Sorry, I added an extra 2 there. You guys might think that you can't do this because you're so used to other roots not working. Well, keep in mind that in this case, what we're saying is that we're taking the 5th root of negative 32. Well, 32 negative 32, is negative 2 to the 5th power, okay? That's another way to write this number. And if you look, the 5th power and the 5th root, they undo one another. And so that's how we would end up with a negative answer. Okay, so it is okay to get a negative answer under a negative number under the root, as long as that root is odd. Okay, so that's the key thing, that the odd root has a slightly different answer. All right, folks, thanks so much for listening. See you back here soon.